Hi everyone, welcome back. So GFG problem of the day today is minimum number of deletions and insertions. We are given two strings str1 and str2. The task is to remove or insert the minimum number of characters from in str1 so as to transform it to str2. It could be possible that the same character needs to be removed deleted from one point of str1 and inserted to some other point. So we just have to perform one of two operations, insertion and deletion, to convert string 1 to string 2, and we have to find out the minimum number of operations. This is the question. Now, how shall we do this? This is the big question mark. So we have two operations, means two recursive calls. We can handle this using simple recursion. For two strings, we can take two pointers. For deletion and insertion, we can make two separate calls and count the minimum number of operations. The recursion will give us the minimum number of operations. So this is what we will do. So moving to the recursive solution in Java, we have created a recursive function fun. We have passed our strings str1, str2. We have created two indexes I and j. Initially they will be at the beginning 0, 0. Now the main thing for recursion is the base cases. So for this question, what shall be the base cases? First base case, if both the pointers reach the length of the strings, means both pointers have reached their end, means our work is done, so we have to return 0, no more insertion deletion, so we will return 0 operations needed. So this is our first base case. What shall be the second base case? One pointer reaches end, other does not reach. So if I is completed but j is left, means string 2 some characters are left, means all the remaining characters we will have to insert in str1, right? So that will be the minimum operations needed. So if I reaches str1 dot length, the answer would be remaining characters in string 2, that will be str2 dot length minus j. Similarly, if j reaches its length and some characters are left in string 1, so we will have to delete all the characters, that will be the minimum operation, right? So if str2 reaches j reaches str2 dot length, we will return the remaining characters on string 1, that is string 1 dot length minus current index I. So these are the three base cases. After this, we have to make our calls, but we want the minimum number of operations. So if the characters are equal, we do not need to perform insertion deletion, we will just move ahead, and we have to find out the minimum operation. So we will keep a variable min, which will be initially integer dot max value. This will store our minimum. So if the characters are equal, we will just move ahead without any operation. So no operation is performed. We move both the indexes ahead plus 1. So this will give us the minimum operations. Otherwise, if the characters are not equal, we will have to perform certain operation, either deletion or insertion. So if we perform deletion operation in str1, means the current character moves ahead, it is deleted, so it moves ahead, right? So this is what we are doing, one operation of deletion plus our I moves ahead because the current character we have deleted in a string 1. So I moves ahead, j remains the same, we have not done anything. So this was the operation for call for deletion, one deletion operation, remaining operation recursive function will give, and our I has moved ahead because the current character is deleted. Now the second call is for insertion, means we are inserting a character, means the character which was not matching from string 2, that character we are inserting in string 1. So in string 1, the jth character of string 2 is being inserted, means the current character I is still there, and we have inserted an extra character, means I will remain the same, and the jth character we have inserted, so j will move ahead because that is matched with the inserted character. So I remains same and j moves ahead because the jth character is matched with the inserted character, and one operation of insertion. So min will keep the minimum of these two calls. So we will have the recursion will give us the minimum number of operations. We will return this min. So this was a recursive function which will give us the minimum number of operations, insertion and deletion, to make string 1 equal to string 2. Now this is very good, this is fine, but the main problem is the length is 1000, so recursion will give TLE, time limit exceeded. Now how to handle that? For recursive questions where we have changing variables, we can store or memoize our answers in a table, DP table, that is recursion plus memoization, top-down dynamic programming. So we will do the same. It is very simple. We have to do nothing once we have written our recursive solution. We just have to store the answers, and if a stored answer is there, we have to return that. So same thing we will do for the same solution. We have created our DP table. What are the changing variables? Changing variables are index I and index j. So we have to store these in the DP. What will be their range? From 0 to string length, right? So we will keep a DP table of string 1 dot length for I, string 2 dot length for j. We have created a DP table. We will pass it to a recursive function. A recursive function will be having DP now. After the base cases, what new condition we will add? If our answer is stored in DP, means our DP ij is not null, directly return our stored answer from the DP. And at last, we will pass DPs in all this calls. And at last, we will store the minimum answer for ijth index in DP and return it. So we have added DP to our recursive solution. Now, I hope you guys would have got how simple DP is. It is nothing big, just write the recursive solution and memorize it. So our DP top-down approach is done. This was the simple solution. Thanks for watching the video. I hope you guys would have understood the solution. Have fun. Bye.